Today, let's continue learning to solve polynomial equations. Yesterday, you learned the fundamental theorem of algebra, that an nth degree polynomial has n solutions. They're not necessarily all unique and not necessarily all real. You learned to factor polynomial equations to solve by factoring out common factors and by grouping. Today, you're going to learn to factor polynomials using substitution and using polynomial division. You'll also learn the factor theorem. The factors theorem says that if x equals a is a solution to a polynomial equation, then x minus a is a factor of that polynomial equation. This means that if p of x equals 0, it's a polynomial equation, and p of a equals 0, this means a is a solution to the equation. Then x minus a is a factor of p of x. Take, for instance, the equation x squared minus 4x plus 3. Equals 0. If I plugged in 1 for x, then 1 squared minus 4 times 1 plus 3 equals 0 is true. And x equals 1 is a solution to the equation. This means that x squared minus 4x plus 3 equals x minus 1 times some other factor. We're going to call that factor q of x. And we can find q of x by dividing both sides of this by x minus 1. We're dividing the polynomial by the factor. And if we do that, you've done polynomial division before. This is a simple one. You could have factored this and found it. But just to show you a more higher degree polynomials, we'll have to use this division idea. X times x makes x squared, so I'll multiply the x on the outside and get x squared minus x. I'll subtract that. The x squares cancel. Negative 4x minus negative x makes negative 3x. Bring down the plus 3. Ask myself what times x makes negative 3x. That's negative 3. And negative 3 times x. And negative 3 times negative 1. And when I subtract, I get 0. The remainder 0 verifies that x minus 1 was a factor. And it allows me to write x squared minus 4x plus 3 as x minus 1 times x plus 3. Sorry, x minus 3. That's using the factor theorem and polynomial division. If we know a solution, to the equation, then we know a factor. If 5 was a solution to the equation, then x minus 5 would be a factor. If negative 2 was a solution to the equation, then x plus 2 is a factor. So, we can use that. Then let's say we have the equation x cubed plus 3x minus 4 equals 0. This is not a quadratic, so we can't factor it using quadratic techniques. We don't know how to factor this, but it doesn't have an even number term. We can't use grouping. It doesn't have a common factor for all the terms, so we can't use common factors. But if we could find a number, such as x equals 1, that made the equation true, 1 cubed plus 3 times 1 minus 4 equals 0, that's true. This means that x minus 1 is a factor. And we can divide x cubed plus 3x minus 4 by x minus 1. Remember, we're missing a term there, so we have to add it in as 0x squared. We'll go through the division. X times x squared makes x cubed. Multiply out here, get x cubed minus x squared. Subtract. X cubes cancel. 0x squared minus negative x squared makes positive x squared. Bring down the next term. X times x makes x squared. Multiply that on the outside, get x squared minus x. Subtract that. X squareds cancel. 3x minus negative x makes positive 4x. Bring down the negative 4. X times 4 makes 4x. Multiply that on the outside, get 4x minus 4. Subtract. That's 0. Verifies it was a factor. This means my initial polynomial, x squared plus 3x minus 4, equals the x minus 1 from the factor theorem times, now x squared plus x plus 4. If this was a nice, pretty quadratic, we could factor it, but since it's not, we're going to set each factor equal to 0 and solve. This was equal to 0 to start with. X minus 1 equals 0. X squared plus x plus 4 equals 0. And we're going to find all the solutions to the equation. Add 1 to both sides, we get x equals 1. Here, since we can't factor it because there's no two numbers that multiply make 4 and add to make 1, we're going to use the quadratic formula. B is 1, so the opposite of 1, plus or minus the square root of 1 squared minus 4 times 1 is a, and c is 4, all over 2 times a is 1. So this simplifies the negative 1 plus or minus the square root of 1 minus 16, or negative 15, all over 2. Remember, we don't leave the negative 15, so we get x equals negative 1 plus or minus I square roots of 15, all over 2. And our solutions to the equation are x equals 1, x equals negative 1 plus I square roots of 15 over 2, and x equals negative 1 minus I square roots of 15 over 2. Remember, the fundamental theorem of algebra said that if we have a third degree polynomial equation, we expect 3 roots, not necessarily all real. These are both complex roots. What we expected. That's an 8-minute video. I'm going to stop this now and let you look at that. And then we'll do another video to finish this up.